So this should actually be a pretty short video because this lesson is really just about individual students becoming increasingly comfortable with their particular graphing calculator. And there's different types of graphing calculators. And so I have a few questions here. And while I'll be using Desmos just because it's easy to use and easy to show, you can't use Desmos on an assessment, obviously. And so for any work with this, the whole point is you try similar things, but becoming familiar with your own graphing display calculator. And so in general, as it says here, anytime you're asked to sketch a function, that means what you're looking for, if you're asked such a thing on an examination, is you want to show the basic shape as well as the x and y intercepts, but that's it. It doesn't have to be the scale, or you don't have to make an attempt to make it to scale. Just the basic shape as well as any x and y intercepts. And you're always allowed in this course to use a graphic display calculator. And so the first thing you want to do is graph this in a fairly simple cubic function to type in. And you should see something similar to this on your screen. Now, if you're using like what most people have, like the TI-84, you may have to, as always, think about adjusting your window settings. Sometimes your initial window settings, you don't realize that other characteristics of the graph that take place outside of the initial window settings. And here, if I just zoom out, you realize I get the basic idea of what's happening to this graph. So I'll go back to this sort of setting here. And now all I need to show on my sketch is this general shape. I don't need to show where these vertices are, so I'm going to just ignore those, but I do have to show my x and y intercepts. And so those are the points I want to show in detail. And so I'll show you an example of that right here. And while you don't need a ruler for any of this, it is helpful for your x and y intercepts. And I'll draw those first. And so next, I'm just going to draw the general shape of what I saw, which, if you have it on your screen beside you, should be fairly quick. It looked something like this, paying attention to the quadrants where my vertices are, but not having to worry about the exact coordinates. There we go. I'm already almost done. So this is my sketch of f of x. All I need to now do is make sure I have my x-intercepts labeled and y-intercepts. So these are my x-intercepts, that's my y-intercept. My y-intercept's at -6, my x-intercepts are at 2, -1, and -3, all of which I could see from the graph. Now on many graphing calculators, especially the TI-84, you can easily convert any graph into a table in which you see the coordinates at specific points, usually whole numbers. And quite often that can also be quite useful to find some of these coordinates instead of just the trace function. But I'm done. There's my sketch. All right, for this, while I want a graph, I'm not asking for a sketch. I'm asking for the x and y intercepts. Now, I will say, you can, in the general idea, the general algebraic idea of how to find x and y intercepts is not that complex, although quite often it's significantly easier, if not much easier, to do so with a graphing device. But in general, if you ever want to find x-intercepts, x-intercepts are where your y equals 0, your y coordinate equals 0. And if you ever want to find y-intercepts, those are where your x coordinates equal 0. So for this particular equation, because remember, if we look up here, g of x, that's our output, that's like our y. If I want to find the y-intercept, I can actually do so really quickly algebraically just by replacing all my x's with 0. I get y equals 2 times 0 squared minus 2 over 0 minus 1. And if I do that, I quickly get 0 minus 2 over -1. 0 take away 2 divided by -1, same as 0 take away -2, which is +2. That said, if I just look at the graph, I can find it just as quickly. And so that's the graph I have here. Now, as usual, no matter what device you're using, always make sure, if it's a function you're not familiar with, to kind of adjust your window settings to make sure you're not missing some other feature outside, but I can see, I get the general idea. And in terms of my y-intercept, all I care about is right there. It's at 0, 2. And I can see there's no others. Keep in mind, if I just focus on this window setting, there may very well be another y-intercept somewhere else. Although if something is a function, that's not going to be possible. Remember, if something is a function, it never has more than 2 points with the same x-coordinate. But anyways, let me answer that. So there's my y-intercept. I'll make it a little more formal. I'll just say here, I'll just write it as at 0, 2. The x-intercept, I will show you the idea to remind you how to solve this algebraically. Although in this case, while it's not impossible, it will be a bit more annoying, so I just won't do it. Because in general, if you want to find a x-intercept, you want to make your y value equal to 0. Or my g of x in this case equal to 0. So I say 0 equals 2x squared minus 2 over x minus 1. Now we can do it algebraically. For example, if I was to solve this algebraically, I would first multiply everything by x minus 1 to cancel out that denominator. But really at this point, what's the point? And you can't assume that everything can be solved simply algebraically. And so while that general idea is important, I'm just going to go back to my graph, which I have here already. I can see there's only one x-intercept. It's at approximately 1.466. So I'll say it's at approximately 1.466, comma 0. And there's my y-intercept. Sorry, x-intercept. All right, last question. I have function h. It's a quadratic function, and if you're familiar with quadratic functions, you can actually visualize x minus 1 all squared, take away 4 quite quickly without needing a graphing calculator. But this time I want to graph that and then use that to sketch a graph of its inverse. And we talked about inverses recently. So, like I said, if you have a familiarity with quadratic functions already, which you may, it's probably actually faster just to graph this using what you've learned about that. I haven't covered that yet in this course, so I'll just go to a graphing calculator, and this is what that looks like. And so some key points I want to show are the vertex, I want to show my y-intercept, and my x-intercepts. So I'm going to sketch that. That's the graph of h of x. Right, those are the points I saw immediately from my graphing calculator or Desmos. I'll sketch that. As well, like I mentioned before, you can get quite often coordinates of points quite nicely on a TI-84 by selecting the table feature, and you can look at the points that have nice whole number coordinates. For example, this point right here I just highlighted at 2, -3. Any sort of points on your table that are nice whole numbers are generally easy to plot. So that is the graph again of h of x. So I want to use this to find the graph of the inverse. Now the graph of the inverse, which we talked about recently, is if you wanted to find it algebraically, you'd have to go to your equation for h of x, replace h of x with a y, swap around x and y, solve for y, and you'd actually get something that's not a function. You can do it, but then I don't know if that equation is really going to help you in terms of what it looks like. More importantly, I think at this point, is to remember that it doesn't matter what your initial function or relation is. The inverse is always a reflection on this line y equals x, which I'll come back here, which I'll show here. But even more helpful than that, perhaps, because if you just look at this reflection line, I don't blame you if it's not immediately. Well, it's a messy reflection line. I don't blame you if it's not immediately obvious what the reflection of this looks like. More helpful, I think, is to remember that the reflection is always the same as any of these points where your inputs and outputs are swapped around. The x and y's are swapped around. For example, looking at the vertex, the coordinate of the vertex is 1, -4. So I know its inverse is going to go through -4, 1. So right here, I know my inverse will go through that point. And if I just do the same thing for a few more points, I'll quickly get a sense of what this looks like. If I look at this point right here, the y-intercept, that's at 0, -3. So I know that's going to become my x-intercept, -3, 0. And as you plot more and more points, you will see that what we have is a parabola opening to the right. It's a reflection along that line. It's not a function. It fails the vertical line test. For many x values, there are 2 y values, but it was quite quick. And so that is the inverse of h of x.